Okay, geometry students, this is section 11.2. Now, in the last section 11.1, we talked about circumference and arc lengths. Now we're going to talk about areas of circles and sector areas. So a sector is just like a piece of a pie. Like if you cut a circle, like if a pizza, cut it into 8 pieces, each of those 8 pieces would be like the area of a sector. So again, we're going to be talking proportions or ratios in order to solve some of these things. So vocab here, sector of a circle is a region bounded by 2 radii of the circle and their intercepted arc. So once again, if I have a circle, here's the center, okay, say I cut my circle into 8 pieces, none of those happen to look congruent, but you get the idea, okay? This would be the area of that sector, okay? That's what they're talking about, that's a sector, okay? Theorem 9 then says the area of a circle is pi times the square of the radius. And I think we all know that area is pi r squared. I think we're all pretty familiar with that, kind of like circumference is pi times diameter or 2 pi r. Area is pi r squared, okay? Now, theorem 10, the area of a sector, the ratio of the area of a sector of a circle to the area of the whole circle is equal to the ratio of the measure of the intercepted arc to 360. Okay, so essentially what they're saying is here, back up to my sad little description, this area would be 1/8 of the whole circle. Okay, that's kind of what they're talking about. We're talking about a ratio. So we would take whatever that arc measure is, okay, that central angle, over 360 times the area of the whole circle. That would give us the area of our sector. Okay, so again, it's all based on ratios. So let me just point out, again, it's equal to the ratio of the measure of the intercepted arc to 130. Okay, so let's look down here at their examples. First of all, part A says find the indicated measure. So we're supposed to find the radius. The area is 201 feet squared. Now, one thing I do want to remind you, when you're talking area, remember whatever your label is, whether it's feet, inches, centimeters, kilometers, whatever it is squared. Okay, if we were talking volume, it would be cubed. Okay, but area is squared, so don't forget to label your answers. Again, remember we have our basic formula, area equals pi r squared, so then we're just substituting in the 201 for the area. Okay, now how do you think we get from r squared equals this to r is approximately 8? R, remember, would be the square root then of 201 over pi. Now, those of you that have had me for algebra 2, you know that when we take the square root, we have to account for plus or minus. However, in geometry, we just have to account for the positive because we're not going to have any negative lengths, okay, or negative radius. That doesn't make sense. So we don't really have to worry about it in the land of geometry here. So that's where the 8 comes from. Okay, in order to go from an r squared to an r, you got to take the square root of both sides. And again, I want to remind you when you're using pi in your calculations to use the pi button on your calculator. Please don't substitute in 3.14. Okay, it's probably not a big deal, but again, the higher levels you get in math, you do not want to round unless you absolutely have to at the very end. Okay, so the more you round, the more you substitute in smaller numbers for others, the more off, you know, the greater the opportunity for error. So look at part B here. Here they give you the radius and they want the area of the circle. So again, you're just plugging in. You start once again with area equals pi r squared. Now instead of plugging in for the area, we're plugging in for the radius, poking that in a calculator, and then don't forget, if you're finding area, it's square inches. Okay. Okay, let's look at some of these examples. So find the indicated measure. The diameter of the circle is 11 centimeters. Find the area. Well, first of all, diameter, remember, is 2 times the radius. Okay, so if diameter is 11, then that means your radius is 5.5. That's the first thing, 11 divided by 2, right? Then you find the area. So your area is going to be pi times 5.5 squared. You poke that in a calculator and you get approximately 95 square centimeters or centimeters squared. Okay. Okay, number 2, the area of the circle is 158 3/10 square yards. Find the radius. Okay, so let's go out here to the left. Again, remember area pi r squared. So we are substituting in the 158.3. Okay, we're supposed to find the radius. So radius squared equals 158.3 divided by pi, right? So this means radius equals the square root of 158.3 divided by pi, which is approximately 7.1 yards. Now remember, if we're just finding the length of something like the radius, we don't have to square the label. Okay, it's only when we're finding area that we have to square the label. Okay, number 3. The area of the circle is 1024 pi square meters. Find the diameter. Now, we know we don't have a formula that gives us diameter right off the bat, so we're going to have to solve for radius and then double it to find the diameter. Okay, so we've got 1024 pi equals pi r squared. Now, first thing that jumps out at me, I can just cancel the pi out of both, right? And then this is going to tell me that r is the square root of 1024. It is really high winds outside and my board seems to be shaking a little. I'm not really sure why. Anyway, then our diameter, remember, is going to be twice that. So our diameter is going to be 2 times the square root of 1024, which the square root of 1024 is 32. So this is 2 times 32 or 64. What are we dealing with? Meters. Okay. Hope that is helpful. Okay, back page. Find the area of the sector. Now, again, we've got this proportion thing going on, okay? Kind of like we did when we were talking about arc length in 11.1. So the area of our sector, okay, is going to be our intercepted arc over 360 times the area of the circle, okay? So let me just write that first of all. Area of sector equals intercepted arc over 360 times, okay, area of the circle. Okay, hope you all can see that. Area of the sector equals the intercepted arc, maybe I should have said intercepted arc measure, over 360 times the area of the circle. Okay, so you can see down here in this example, the area of the small sector is 160 over 360 times pi times 10 squared. Okay, again, that 160 over 360 is what gives us our ratio, our part of the circle. So essentially, we're just finding the ratio of the shaded, okay? And then the area of the large sector is going to be what's left. That's the 200, okay? 200 equals the 360 minus 160, okay? That's where the 200 comes from, okay? Oh, they have it up here, sorry. Over 360 equals pi r squared, or pi times 10 squared, okay? So let's go down here. Look at their example 3. Use the area of the sector theorem. Okay, area of sector XYZ is the measure of the arc over 360. Now, measure of the arc, you can talk about that's the intercepted arc, that's the central angle, whatever you want to reference it as, times the area of the circle. Okay, so they have the area of the sector is 95. So 95 equals 150 over 360 times area of circle Y. So we know that 228 is the area of the circle. If they'd asked for the radius, we'd have to break that down further, okay, and know that 228 equals pi r squared, and then solve for r. Okay, let's look at these two examples. Number 4 says find the areas of the sectors. Okay, kind of want to point out the S here, sectors formed by angle ABC. First of all, let's do shaded and then unshaded. Okay, so let me talk shaded area first. Okay, again, area of a sector equals the measure of that arc, okay, or the measure of that central angle over 360. So this is going to be 110 over 360 times the area of the whole circle. So that is pi times 21 squared. Okay. Again, intercepted arc or central angle over 360 times pi r squared. Okay. So if you poke this in your handy dandy calculator, that is going to give you 423.33, and we're talking millimeters. So since we're finding area of a sector, it's going to be millimeters squared. Okay, now that's the shaded. Okay, let's do unshaded. Okay, unshaded. Now, if the shaded area is 110 degrees, what do you expect this to be? Okay, well, 360 minus 110 is going to be 250, right? Y'all see that? So that's 250 degrees. So we have 250 over 360 times, again, pi r squared. Okay, 250 over 360 times pi r squared. Poke that in the calculator and you get approximately 962 and 11 hundredths meters squared. Okay. So how could you check yourself? One way to check yourself is to add those two areas up and see if they add up to the whole area of the circle of pi r squared. Okay, it's one way to check yourself. Not going to take the time to do that, but that's how you can do it. Now, number 5, find the area of circle H. Now here they give us the area of the sector. Okay, so we have to work backwards to get the area of circle H. So we know that 123.45 has to equal, this is where we get our ratio, okay, our central angle over the total measure of angles in a circle, 360, 70 over 360 times area of the circle. Area of circle H. Okay, now to get that 70 over 360 off the area of circle H, we have to multiply by the reciprocal, right? So I'm going to flip-flop. So this is going to be 360 over 70 times 123.45 Actually, let me do that. Equals area of circle H. Okay, again, got to multiply by the reciprocal to get a fraction off, right? Because you're doing the opposite operation. So if we poke this in the calculator, the area of circle H is approximately 634.89 meters squared. 634.89. Okay, that is the area of the circle. Okay, hope that helps. Let's look at practice A. Okay, practice A, just going to do a few of these. Number 1, it says find the exact. Again, want to point out the word exact. So like I said back in section 11.1, when you see the words exact, you're not going to poke pi in a calculator. You're actually going to leave pi in your answer. Okay? And they want both things here. They want exact area and then find the area to the nearest hundredth. So you got to give both. Okay? So first of all, once again, area equals pi r squared. So this is pi times 2 squared or 4 pi. That's the exact. Okay? Then poke that in a calculator, 4 times pi, and you get approximately 12.57. Uh-oh, you know what I forgot on this first one? Inches squared. And again, that's the exact answer. Okay? Poke it in a calculator, you get 12.57 inches squared, and that is the approximation. Okay, that's the rounded one. Okay, so 4 pi inches squared and 12.57 inches squared. Got to do both. Okay, now 4 through 7, it says find the indicated measure. The area of a circle is 58 square inches. Find the radius. So all we're doing is working backwards. Okay, so again, area equals pi r squared. So if our area is 58, okay, and we have to find the radius, then that means the radius squared is 58 over pi. That means that radius is going to be the square root of 58 over pi, okay, which gives us, if you poke that in a calculator, 4.30 inches. Okay. Again, we're talking measurements here. Don't forget to label your answers. Okay. Next section, 8 through 10, it says find the shaded areas, or sorry, find the areas of the sectors formed by angle ACB. So they want both shaded and unshaded. Okay. First of all, one thing I'm going to do number 10. One thing I noticed here is all 3 of these are congruent. Okay, so if all 3 of those are congruent, what is 360 divided by 3 is 120. So each one of these is 120. Now, each one of those is 1/3, right? So if I'm going to find the area of the, let's start with the shaded. Okay, if I'm going to find the area of the shaded, it's going to be 1/3 or 120 over 360. Okay. 1/3 times pi r squared. Again, let me point out to you that the 1/3 comes from 120 over 360 reduces to 1/3. That's where the 1/3 comes from. Okay. If I poke that in a calculator, I get approximately 603.19, and this should be feet squared. Okay. Now, if I want unshaded, Okay. If I want the unshaded, if the shaded is 1/3 the area of the whole circle, then the unshaded is 2/3 the area of the whole circle. Okay, 2/3 times pi r squared. So again, poke that in my handy dandy calculator and I get 1206.37 feet squared. Now, you can also keep in mind 2/3 is twice 1/3. So what I actually did on this one, I wanted to set up both of them, but what I actually did was took this 603, I took this times 2, okay? And that gave me that. Now again, there's some rounding things there, okay? So I had the exact answer in my calculator when I went to round it, or when I went to calculate, take it times 2. So then obviously I'm left with a 0.19 on the first one. If I double that, I'm gonna end up with a 3/8. That again, another reason not to round. Keep as much exact in your calculator as you can. But to get from the purple to the blue there, from the shaded to the unshaded, you're essentially doubling it. Okay. All right, let's look at number 12. It says use the diagram to find the indicated measure. Find the area of circle S. Okay. Now, they give us the area of the sector. This is area of the sector. Okay, I'm assuming shaded since it's on the shaded side. So area of the circle. So remember, your area of the sector equals the ratio of the angle measure over 360 times the area of the circle. So our setup is going to be 39.52 equals 175 over 360 times the area of circle S. Okay. So this means, again, I have to flip-flop this. So this is 360 over 175 times 39.52 equals area of circle S. You could have also set this up into a proportion. And so then you poke that in your calculator and you get the area of circle S is approximately 81.30 inches squared. Now let me say something here. Most of these we've been rounding to the hundredths, okay, because that's what they told us in the front and that's what we did back on 11.1 as well. So why would I put 81.30 as opposed to 81.3? Okay, I would do that because if they're telling you to go to the hundredths, you need to list every place. Now, again, being a little too formal here, I wouldn't necessarily care, but you do need to be aware on like a standardized test. If they tell you to round to a certain place, you better have a digit holding every one of those places, okay? Because it comes into play a little more when we talk about significant versus insignificant digits, and I don't want to get off track here, but just keep that in mind, okay? Backside, I'm going to do just a couple. Now, 14 through 19 are interesting. It says the area of circle Z is 124.44 square centimeters. The area of sector XZY is 28 square centimeters. Find the indicated measure. Now, let's do number 14, okay? But I'm going to do it over here. So give me a little more room. So this is number 14. First of all, if they gave me the area of the whole circle, it's pretty easy to find the radius, because remember, area equals pi r squared. So my area is 124.44 equals pi r squared. So r, I'm going to kind of jump ahead, is the square root of 124.44 over pi. Okay, so if you poke that in a handy dandy calculator, you get approximately 6.29 centimeters. Okay, so radius is 6.29 centimeters. Now, you can use that, and if it were me, they really didn't tell us again what to round to. The answer key rounds to the hundredths. I would probably take it to 3 or 4 places, just to kind of have, but you may be able to use that calculation then in these further ones. I just want to give you a hint here on number 18. Okay, number 18, my hint, when they're asking for the perimeter of the shaded region. The perimeter of the shaded region is this, this, and this. Okay, so it is the arc length xy plus 2 times the radius. Okay, so remember, this would be a radius and this would be a radius. Okay, if it's circle Z, that means Z has to be the center. So again, from the center to the outside obviously is a radius. So obviously you can tell I couldn't hardly draw a straight line here, but these two are radius or radii, okay? And then this, I don't know if you can see me tracing it, is your arc length xy. So that would give you your perimeter, okay? Your arc length xy plus r or plus 2r. Okay, that's my hint for 18. Okay, 20 through 22. Let's do 22 together. And then that's the last one I'll do here. Now it says find the area of the shaded region. Okay, if we're going to find the area of the shaded region, a couple of things here. First of all, the area of the shaded region is going to be the area of the circle minus the area of the square. I hope you all can see that. Okay, now, first thing we need to do is find the area of the square. Okay, so off to the side here, I'm just going to work on the square for a minute. Okay, I have got, this has got to be 90 degrees. How do I know that's 90 degrees? I know that's 90 degrees because the intercepted arc is 180, right? And your inscribed angle, remember, is half of the intercepted arc. Do y'all remember that? Back from chapter 10? Okay, your inscribed angle is half the intercepted arc. Well, if half the intercepted arc, first of all, if the intercepted arc is a semicircle, that means it's 180 degrees. Half of that is 90. So I know that's a square. Okay, so let me call this side X and this side X. I kind of flip-flopped my triangle, not really sure why. But if this is 16 and this is X and this is X, I can use Pythagorean's theorem, right? This is going to be x squared plus x squared equals 16 squared. Okay, I hope you guys see that. So this is 2x squared equals, I believe that's 256. Okay, so then divide by 2, x squared equals 128. Now, if you figure out then what x is, take the square root of that. That is 8 root 2. Okay. Now, let's go back then and finish the area. Okay, so area of the circle. So area of circle is going to be, first of all, what's my r? Okay, from here to here would be my r. Well, if the diameter is 16, the r has to equal 8, right? Okay, so area of my circle is pi r squared minus area of the square. Remember, area of a square is the length of one side squared, right? Or length times width, they just happen to be the same measurement. So this is 8 root 2 squared. Well, this gives me 64 pi minus 128. 64 pi minus 128 is approximately 73.06 square feet. Okay. I hope that makes sense to you guys. I want to do that one because that's probably the trickiest one of the whole bunch. Okay. That concludes section 11.2.